All right, so question 5 is what I often term the bread and butter type of question. These sorts of questions that we set up, this one-step transformation, these are things that we expect you to know. You must know this kind of work to get your 50% to pass the course. And so each of these is just testing a fundamental transformation that can occur. And so I just want to take you through these. Almost always you'll see they're worth about 2 marks, and you can really score big here if you just know what to look for. I have to confess that when I set this question up, I think it was slightly differently, and then I realized that in some respects this was a bit of a silly question, but then afterwards, looking at the way people were answering this, I think it actually shows how there are some confusions. Just analyze a molecule. When you get a question, you see this over here. You see that you have the carbon-bromine bond is immediately saying this is a leaving group. The OH group, it is not a leaving group. And then we couple the looking or the understanding of this to the reagent that we've got. And we see we've got sodium hydroxide, all right, that's Na plus OH minus. OH minus can act as a base or as a nucleophile. And the one thing we expect you to learn from this or to know from this course, and it's not 100% this way always anyway, this is just the way we want you to just answer these questions, is that when sodium hydroxide is used in water, the hydroxide acts as a nucleophile. All right. So OH is not a good leaving group. Bromine is a good leaving group. And so it can do a substitution at that point, and we get just that acting, being substituted. And so this OH stays exactly where it's supposed to be. All right, it's exactly over there. I've just drawn this a bit messy. That's why we do this in pencil. I encourage you use pencil so that you can erase things and make it look neat afterwards. All right, nothing happens with this. This is not an elimination reaction. It's not the 2 of these going off and forming double bonds. All right. Same story. We look at a molecule over here. Bromines, very good leaving groups. Chlorine, a good leaving group, but not on an sp2 center, not on an aromatic ring. Okay, so they're good leaving groups. What about the reagent? Well, we're using sodium amide, right? Again, Na plus, N minus. But N minus is a super strong base. It very, very, very seldom, if any times, will act as a nucleophile. Only if it cannot act as a base will it act as a nucleophile. So you just need to remember that you see something with an N minus on it, it is a super strong base. Bases do elimination reactions. And we've got 2 protons that are alpha to those bromines. So we can remove the 1 proton, kick out the bromine, and we can do it a second version. I'm just doing it on the same sheet here. It's a bit messy. I apologize for that. We can remove the second proton and actually kick out that bromine as well. And so we're going to form a triple bond there. And this, again, as I say, was done pretty badly. Remember that because you're forming a triple bond, it needs to be linear like that. And don't forget that the chlorine remains. All right. Yeah, if you got something like this wrong, then you would have got 0. If the bonds were kind of kinked a bit, so you hadn't done them straight out, you would have lost half a mark. All right. This one, I saw weird and wonderful answers. Wow. This, all right, if we look at this whole molecule, we've got a double bond. It's not very reactive. We've got esters, all right, and so there's no leaving group. There's no things where you can think of substitution, elimination. Then we go to the reagent. We've got sodium hydroxide. Sodium hydroxide is a good base. And it is also can be used as a nucleophile. And when we think of sodium hydroxide mixed with an ester, you've just done the prac now, you're busy in this, this is practical 5, we are thinking about a hydrolysis of the ester. And that's all that happens. Sodium hydroxide is not going to do anything to the double bond. All right, the only thing we do with double bonds is the addition reactions where we're using acids or the hydroboration reactions. So with an ester, sodium hydroxide is going to do this hydrolysis. And you don't some of you might say, oh, but why is there not water if you're doing hydrolysis? If you follow the mechanism, I'm not going to do the mechanism here, but if you follow the mechanism, you actually don't need water for this. And so the answer is the carboxylates minuses, because we're doing it under basic conditions. And I was fairly generous with this reaction. I just marked this as being the answer. If you got that right, you got your 2 marks. If you left off the charges, you got 1 mark. All right, the charges were important. If you put hydrogens there, all right, then that was also incorrect because it needed to be the carboxylate, and then you got 1 mark. I didn't actually mark the side products, but you should have written methanol as being a side product in this, and the sodiums are just associated with the negative charges. Some of you wrote Na next to the oxygen, and that was fine, and I gave you the marks for that. All right, now this is one of the first questions where we're having to think backwards, and looking at something like this at this stage in these types of reactions in terms of the class test, you've only done substitution and elimination reactions. So if you're ending up with a side product which is kicking out bromine, and there are 2 of them, it means that some sort of maybe an elimination reaction or a substitution reaction has occurred. We look over here and we see we're using sodium hydroxide, and then we see that we're doing this using sodium hydroxide and water, just like we did in that first question. And so that means that this reaction must be whoops, sorry about that. The world is going crazy. This must be a substitution reaction. And because it's a substitution reaction, this double bond could not have arisen via some sort of elimination. That double bond must have been in the starting material. So if the double bond was still there, we did a substitution over there, and there are 2 bromines that were eliminated. And so if we substituted this, we would have had the 2 OHs, and then that we know is very unstable and immediately eliminates and goes to the ketone. All right. So this was a bit more of a tricky question, all right, but yet actually quite a lot of you got this correct. Some of you, just again, look at the balances of the reaction. Some of you gave answers where you were doing stuff like this, and if you think about it, this cannot go to that. You were thinking of maybe an elimination and then some sort of substitution. Some of you might have even put 2 bromines there, but then you've got 3 bromines and the balance is just with 2. So yeah, just watch out for that. This one is a double elimination. All right, we're going from where we've got functional groups and we're putting on double bonds. For that to work, we've got to change the OH into a leaving group. For that to work, the only way to change an OH into a leaving group is to add a strong acid. And you know that if you add HCl, what does it do to an OH? It changes it to a chlorine. If you add HBr, what does it do? It changes the OH to a bromine. So we can't be using those acids. The acid that we want to use is sulfuric acid, and only that one, because that's a very concentrated, a very strong acid, and it's very good at dehydrating, which is what this reaction is doing. To get that double bond, we're taking this OH off, and one of the hydrogens that's over there, we're removing water to get the double bond. It's a dehydration reaction. So the sulfuric acid, in order for this to work, it actually needs to be concentrated. If you hadn't written concentrated there, I probably wouldn't have marked it. I would have still given you the marks. If you wrote sulfuric acid, that's fine. I was feeling generous with that question. However, if you wrote water here, then water makes the sulfuric acid no longer concentrated. So you would have only got 1 mark. I would have taken a mark for writing water. If you wrote alcohol there, well, just think about it. What is an alcohol? An alcohol might be something like ethanol. Well, ethanol is an OH. So if you mix sulfuric acid and ethanol, it's going to react with this, just like it reacts with this one. So if you wrote that, you also got that wrong. And some people wrote like they put in sulfuric acid, and then they'd write like potassium hydroxide here. Well, potassium hydroxide is a base. It's going to destroy the sulfuric acid, and then the reaction couldn't work. And in that case, I just gave you 0 because that wouldn't have worked. Now this, the last question, is slightly tragic in the sense that I could actually see that a lot of you knew what to do, but you made one very fundamental mistake. So you recognize that this was a good leaving group, bromine could leave, and you recognize that the only thing that could be a nucleophile or something was this carbon with a negative charge on, and so that's going to want to do a substitution reaction over there. You all got that aspect perfect, but the answer that you gave me, and a lot of you gave me this answer, was this. And here's the problem. The nucleophile has 1, 2, 3, 4, 5 carbons. The electrophile has 1, 2, 3, 4 carbons. So 4 plus 5 gives us 9 carbons. The product must have 9 carbons. We're not losing any carbons in a substitution reaction. We're forming a carbon-carbon bond. Over here, 1, 2, 3, 4, 5, 6, 7, 8. See, the mistake here was we lost the carbon, all right, that the bromine was connected to. Here's the nucleophile, all right, and it is connected to the carbon that the bromine was connected to, which is connected to those two groups there. For goodness sake, people, please, this is not for stupid people to do this. This is for clever people to do this. Number your carbons and you won't make this sort of mistake. All right. The triple bond is connected to carbon 1. The triple bond is connected to carbon 1, which is connected to carbon 2, which is connected to carbon 3, and connected to number 4 over there. All right. So many of you people you'd written out the other one. I could see that you knew what you needed to do, but I couldn't give you the marks because it was incorrect. All right. Right, that's questions 5.